Hello, I'm Robert, a fact checker and science blogger and helping people who are scared of various things. And this is about whenever we get a story about a fireball, and it's quite a dramatic one in China recently. And so people get very scared of these, but these fireballs are absolutely normal. So you look at all these dots. These are all previous fireballs, and you see them all over the world. These are harmless. These are burning up in the upper atmosphere. Now, the only one that caused any harm there is this one, the Chelyabinsk one. That's the biggest one in recent times. This one here, then, it caused no harm to anyone. It was over the sea, and I don't think anyone even spotted it. And most of the Earth is, of course, sea. So if you had a really big one like that over here somewhere, then nobody's going to be affected. Nobody's even going to notice it, especially if it's cloudy, unless you're nearby on a boat or something. And so, well, I've talked about that previously, about how we discover most of these asteroids. We actually discover a few of even the very small fireballs a few hours before impact. And this was an example in 2018. There's several more of these that they've discovered. And they discovered that orbit, they predicted where it was going to hit Earth, and then people actually spotted it, and there's an example of a dramatic fireball, but it was completely harmless. And these are all the people who spotted it in southern Africa, in region. And so that's all I was going to say. And the most likely, well, let's just very quick look at that, but we've been there before. So this is about I should have brought it up before starting this. Give me a minute. This is about that's it. Let's just quickly go through this video, this article. So this is a graphic I did about how the most likely next asteroid is going to be just a harmless splash in the ocean. If you have a twiddle down here and look at these numbers, if you look at, say, where have I got an example? I've got a graph here somewhere. So that's the Chelyabinsk one. This is the very one that the last time was a very big one happened was 700,000 years ago. For the last 1 kilometer one, that was back in the time of before the Neanderthals, in Homo erectus. So these are extremely rare that we have a really big asteroid, and we found nearly all the ones at that size. And I don't seem to be any headed for us this century, which is no surprise, because there haven't been any headed our way for 7,000 centuries. And there are few left to look to notice, but of all the ones we've noticed, they're none headed our way, and it's exceedingly unlikely in the few that we haven't yet looked at that they're headed even now a century, most probably centuries in the future. We found one, 1950 DA, which is due, which has a very, very remote chance of hitting in 2,880, 4 centuries from now. So, and those are bits of the tektites thrown up by the 1 kilometer asteroid, and these are the stone tools of Homo erectus, which are amongst the tektites. Anyway, so the ones that are more likely to hit us are much smaller, and this is the Chelyabinsk one. This is the glass thrown, blown in from the windows, and this is where it happened. And quickly look down. So now, if we look at all the future asteroids that are going to hit us of Chelyabinsk size. So some people got damaged by flying glass, and some got sunburn because it was quite bright in the upper atmosphere. Although they talk about the equivalent of so many nuclear, such the size of a nuclear bomb, it's not nuclear, it's not radiation. It happens very high in the atmosphere. All you see is like a little miniature sun, and if you're close enough, you can actually get sunburnt if you look at a very bright asteroid close up, and generally just little bits survive to ground level. This little thing that I did worked out. Now, if you look at the area of the Earth, then most of the asteroids, if we have these asteroids in the future, you can expect most of them to land in the sea. Then the remaining ones spending in ice sheets, in crops, in forest, in deserts, in grassland. And if you have urban and semi-urban area, it's only one out of about 100 asteroids. So over the next 10,000 years, you can expect maybe one of any particular size of asteroid to land in an urban area, and most of them will not land there. So that's why I said the most likely, by far the most likely, is a splosh in the ocean. It'll be a very dramatic splosh. Here we go. Now put that. This is actually to scale. That little. Oh, how did you do that? Click on that. Does it go up? Something funny going on. Anyway, the if you look at that, see that little plane there? That's to scale for the size of the splosh. So it would be a very dramatic splosh in the middle of the ocean. But it so happens that the tsunami type waves, they don't spread very far. If the only reason tsunamis spread so far is because the wavelength of this tsunami is more than 20 times the depth of the ocean. It's a very, very large region of the surface of the floor of the ocean, maybe 100 kilometers suddenly falls, or suddenly rises by a meter or so. That's what leads to these tsunamis that spread over the oceans. Very small ones just splosh, and they don't spread. They've got to be very, they've got to be have a wavelength which is how broad they are that way. And it's just a little splosh like that. So if you have a 50 meter diameter asteroid lands in the sea, then you're just going to get a splosh. It could be very dramatic, but if you can predict it, then I bet you get people flying past to watch this splosh as close as they can go safely, and you get this huge curtain of sea that will go up for 100 meters or more in the air, and more than that. And just to give an idea, I've got an image, an answer there about how high it is. That's what you'd expect. And so that's an actual simulation of an asteroid splosh. Anyway, that's compared with the size of the plane I did, more or less to scale, so you get an idea of how huge it is. Oh, it's taking several hundred meters in the air. Big splosh. But then it creates a little hole, and it immediately sucks the sea back in again. And you get a little splosh, then it gets sucked in, and you just get a big wave close by, but it soon fades away to little ripples. And that's the most likely next impact that we actually predict. This is the fireball from this Perseids, and most of these fireballs you see are like that. And so I'll keep this quite short too. That's how I've already been on that page. That's Shudderbinsk, that's the Bering Sea one. And that's more detail of the Bering Sea one. And that was it actually spotted from a satellite. They captured it, but nobody saw it from ground level because the cloud got in the way. So this is about how we are detecting nearly all of them in advance. So if they are big enough. So if they are above 1 kilometer, you're almost certain to spot them a long time in advance. And then as they go down to like 100 meters, you spot maybe 60%, and as they go down, it's like 40%. This is just with the Atlas observatory, and there's several. There's something playing up there. So there's some. So the but we have several others as well, and over the next decade, this is gradually building up capacity. We've got the large whatever we call the LSST, and it's got another name, which has the Vera Rubin telescope, I think it's called, and that's going to be make a huge difference in how many they can spot from the ground. And a big space telescope would make an even more enormous difference. But by the 2030s, we're going to be discovering just about everything, even down to fairly small. And then 2040s, 50s, I think we'll get to the point where you can just look at your app and you can predict them in hours, days, weeks in advance even. So depending on the size. This is if you have an asteroid and it breaks up, this is the size. See that tiny little thing they're looking at there? Look bigger in the photographs, but if you have one of them breaks up in the atmosphere of something that's a meter or two in diameter, you get little things like that, pebbles falling out of the sky. And it's entirely possible that you could have a pebble fall on your head and not realise it came from a meteorite. So they break up into lots of little like fine gravel, and then you know the mass falling off the Empire State Building doesn't even hurt itself when it hits the ground. And so they're a bit like that, the very small ones, and they can't really harm your penny falling off the Empire State building. So you do get larger bits, but and then you get the rare iron meteorites. I think I might have that's quite an old one. That's quite a big iron meteorite. Create something like that. That would be an estimated mass of 10,000 tons, which seems an awful lot. And obviously, if you were on ground zero of that, you're not going to survive it. But it burnt vegetation up to 6 kilometers from the impact site, and that was about 7,500 to 7,600 BC. So it's originally we would want to spot something like that well in advance, and we've got the Tunguska impact 1908. So these happen every few thousand years or something, something like that, or a little bit bigger. And so we definitely do want to spot not just the big ones that all the fake stories that never been in single NASA asteroid warning, and but we can expect every few thousand years, and then we can have things like Chelyabinsk every century or so, and we can expect to have these asteroids, most of them because of the size of the Earth, are happening over the sea, in the sea, or very remote in deserts or grassland or forests or things like that. And so certainly, and here's an example from where is this Haviland crater? That was quite a recent one. And yes, this is the now known as the Vera Rubin Observatory, I think. This is about deaths by asteroid impact. And so, as I said, small bits do fall out. And there's this one example: 28 people were killed and 28 injured in a hamlet in Mexico in 1946. And there were 3 reindeers were killed and others were other reindeer herders. I mean, not reindeers. A herd of reindeer were killed, and 3 reindeer herders in the Tunguska impact in 1908. So you do get occasional deaths from meteorite, but this is exceedingly rare. In the United States, there's never been a recorded case of death by meteorite. There's one case of a lady who was very badly injured, died to the extent she needed treatment in hospital, very bad bruise. That is the only casualty of meteorite in the United States ever, and in recorded history. There's a fake one from 19th century, which is just a fake, it turned out to be. And then there's, by comparison, there's one death by hailstone in the year 2000 from a pizza worker who saw the hailstones denting his car, so he went out to his car and drove it away to safety. Then he got out of his car and he was killed on his way back. If you see hailstones big enough to damage your car, don't go out, because you're more easily damaged than your car. It wasn't a sensible thing to do. There used to be more deaths in the United States before then, when there were lots of people working out of doors with in agriculture, and then they'd have hailstones fall on them, and the very biggest hailstones can kill you, and if you can't get back indoors when you have a sudden hailstorm, then there's a risk from if it's got very, very big ones. Small hailstorms don't hurt you at all, of course. So that's a very rare death, not very rare for anyone to die of hailstone. You get 20 people a year die of lightning in the United States, and that's a very rare death. Then you've got the hailstone deaths, which are nowadays especially very uncommon. But then if you go and look at the deaths from asteroid, they're much less common than either of those. So it's not really, you should be much more concerned about things like crossing the road safely, or being careful in your home and not falling down the stairs, and keeping you in good health. It's far more important than worrying about asteroids. And but we are on it, and with the world as a whole, with 7 point whatever billion people, it is important to be careful about asteroids, and we are looking out for them. We have very good asteroid detection programs, and we're improving them all the time. But there are ways we could greatly increase them with the if we have this synthetic aperture, which is a way of very rapidly you restack the images in many different ways from CCTV. You can find the near-Earth asteroid even if it's not noticeable in any individual image, it's just noise. But by stacking them in different ways, you find it very quickly. And with using those, we could actually find asteroids for, I think they've got down to less than $100 million. If any of you watching this are a billionaire and you've got a spare $100 million in your pocket change, then you could be very popular in the actual asteroid search community by paying for a constellation of 4 or 8 satellites to go into orbit to detect some of them very early. And there's another method of detecting them. If you prefer that, then I don't have I got it here. Yes, this one. This involves just 2 satellites, and this is an early warning system. So if you want to sponsor an early warning system, it's a Russian idea, and they would hover close to the L1 position. They give about 2 days warning for most asteroids. 12 to 24 hours, sorry. 1 day warning, several hours warning, enough to have an alert and say, and maybe some evacuation and alert. But since mostly you're going out in remote places, and you get an alert on your mobile phone saying your reindeer herder saying you're heading in a place where there's just going to be an asteroid is going to be hit in this place. Get out of here as quickly as you can. And with so much mobile phones in the world, you can imagine that if you signed up to an asteroid alert, and you had something like this that would give you a few hours warning, then that could save even those few deaths that we do have, quite a lot of them. It would spot them from the direction of the sun, where the other ones that are doing early alerts are not able to see them, so especially the very small ones. And so the difficulty is that NASA could easily cover this, with the NASA budget, could easily cover lots of asteroid detection. The problem is that their remit is to do space science. They don't have a remit to send satellites into orbit to look for asteroids. It's ring-fenced, it's got to have a science value. So it'd be very difficult to explain what the science value is of this. It's got tremendous value for protecting humans. It's not got a very clear science value for learning about the properties of asteroids. So it's a funny kind of loophole. You can get hundreds of millions, you can get $1 billion for building a spacecraft, a space telescope on the ground, where you are helping with the asteroid detection. But it's very difficult to find $100 million or less to put some spacecraft into orbit for early detection of asteroids. It's a kind of loophole, a kind of gap in funding in the United States. The United States puts most funding of all into detection of asteroids. They've got a huge funding of detecting asteroids, early detection of asteroids, but NASA is not permitted to allocate even $100 million for this, unless their laws, their guidelines are changed, or they get a special, I think they should have a special bill go through Congress to put some of these in orbit. I don't know why they don't do that. Add $100 million and get early warning of small asteroids, and maybe as part of their. I don't know if Biden's got any interest in this. I know Hillary Clinton did. Hillary Clinton had interest in this. If she'd been president, then she would have wanted to find some funding for this sort of thing. I just don't know about Biden. Anyway, so but then just got to. It's not a personal risk. It's a risk for the world, and so yes. What if the Egyptians had developed asteroid detection telescopes? No, it's just not working for some reason. Some glitch in some glitch. Yeah, I'll sort it out. But probably I just need to. Maybe I'll just go back like that. Maybe it'll work now. Is that it? Yes, that's all it is. When it's full screen, and for some reason Core is not doing that. Okay, so yes, so that's a little image that I'll finish on. That what if the Egyptians had developed asteroid detection telescopes? They would still be waiting for the first city killer impact. By the way, I noticed that I seem to have gone a little bit quieter on my previous video, so I'll to speak up a little bit more in future and talk a little bit more deliberately, and I think I may have gone quiet this time as well. So anyway, never mind. Hopefully this has improved the volume a little bit, and I don't know why I went quiet. I do that sometimes, and maybe something to do with affecting my ears or something. You know, I'm kind of quite sensitive to sound, so it sounds to me as if I'm speaking loudly, and then when I get it played back, it turns out it's quiet. So anyway, I need to readjust. Maybe something is cleared in my ears or something, and I'm hearing things a bit clearer, and so they sounded louder when it wasn't. Anyway, I need to adjust and start speaking at a higher volume again, and hopefully so that will help for the future videos. I'll just upload this.